Good morning, friends. It is Monday, April the 20th, and I hope you had a good weekend. A couple of just housekeeping issues. I did post a video kind of explaining the last 3 weeks of the semester because we have 3 weeks left. And the last week is finals week, and I kind of talked about the final and how that would go. So make sure that you watch that video. Also talked a little bit how to improve some grades in WebAssign for the simple reason that some of you guys are not reading how they want the answer, so you're missing problems because it's asking for 2 decimal places and you're giving a whole number, or it's asking for a whole number and you're giving 2 decimal places. So you've got to read and talk about and put in what they're asking for to make that work. So just kind of some helpful hints there. Let's see. This week we're finishing up our lessons. So we will finish with lessons on Wednesday, and then we'll have a quiz, and then I'll give the review on Friday. So make sure you look at the week at a glance to kind of know what's upcoming. And we'll finish up chapter 4 today. So what we want to look at today is some applications for the natural exponential. So this is looking at growth and decay problems. And the first one I want to look at is exponential growth and decay. So anytime you look at an exponential function, it's something that gets really big really quick. And so it is denoted by this formula right here. N of t is equal to n naught, and that's how we say it, n naught e to the k times t. N naught is equal to k times t. Now, what those pieces mean, so n naught is your starting value when t is equal to 0. So it's your starting population, or it's your starting, whatever you're starting with, okay, whatever you're dating or looking for growth and decay, it's your starting point. K is constant at that point, okay? So then we have n naught, and then we have our e, which is our natural exponential, and then we have our k, and k is what's going to tell us whether it's a exponential growth or exponential decay, and it's depending on whether k is negative or positive. And then we have our t. T is equal to time, how much time has passed. And so what we can do if k is positive, it's going to, your function is going to increase from left to right. If k is negative, it's decreasing from left to right. Okay. So how we do this is the first thing we have to do is we have to create our exponential growth function. Okay, so how we do that. A city had a population of 53,700 in 2002 and a population of 58,100 in 2006. So in a span of 4 years, it grew from here to here. Okay, so that means our n naught is our starting point, so 53,700. Okay, and then our t is going to be 4 years from 2006 to 2002. Okay, so 4 years. Now our n of t, and when we're creating our function, our n of t is our ending point. Okay, so n of t is our 58,100. So I've set this up. 58,100 is equal to 53,700 e to the k times 4. Now to solve for k, that's what we're trying to find right now, is our k. To solve for k, I want to first divide by 53,700. Okay, so I get my division, and then I have e to the k times 4. Now, to get our 4k down front, I have to have either a log or a natural log. Now, because we're working with a natural exponential, I want to take the natural log of both sides. Okay, so this is like solving an exponential, but instead of taking the log of both sides, I want to take the natural log of both sides. And the reason I want to take the natural log of both sides is over to the side, the natural log of e is equivalent to 1. So if I take the natural log of both sides, I bring down my 4k to the front using my power principle. I then get natural log of e is equivalent to 1. So that goes away. And I'm just left with 4k equal to the natural log of 58,000 divided by 53,700. From there, I can divide by 4, and I'm left with k is equal to the natural log of 58,000 divided by 53,700, and all of that divided by 4. And you end up getting 0.0193. Okay, 0193. And so from there, remember, our goal is to write our, sorry, my nose is running this morning. Okay. The sun is shining now. It's beautiful. Okay. One moment. Okay. So the goal is to write our exponential growth function. And so we want to come down here and we want to write it in general terms. N of t, we don't want the ending point at this point. Our starting point, again, 53,700, E, and then our K that we just found, and then T. And the why we want to find that equation is now we can take that and we can use it to predict what's going to happen in the future. We know what happened from 2002 to 2006, but now we want to know in part B what happens in 2014. Okay, so a lot of cities use this to predict their growth of the city or their decay of the city for population. They will use this when we have the census completed. So here's kind of a note. If you have not completed your census form, make sure you do that and get it done. Because they use this to predict what populations will be if it stays constant. Okay, whether it's going to grow or whether it's going to decline. Okay, so part B, we have our formula that we just found. Okay, and we want to predict the population of the city in 2014. Well, we started in 2002, so 2014 is 12 years. So we want to substitute in N of 12, and this is just like solving, substituting in and solving. Okay, now you can do this in your calculator, just straightforward, or sometimes with some calculators you'll want to do your exponent first, then take the natural log, then multiply by 53,700. Okay, you get 67,695. But again, remember it says round to the nearest hundred, so make sure you're reading the problem. So 67,700 people approximately in 2014. Okay, so this is a way of prediction. So there's a couple of these in the homework that you can see, okay, and try. The other thing we want to do with our natural exponential is we want to do compounding interest, okay, compounding interest. And so you have your formula for compounding interest, okay, and you have your A equals P times 1 plus R over N to the NT, okay, NT is what that formula says. Okay, it reads better on your notes, okay, where it's not scanned. A is your total, so that's your principal and interest together. P is your principal, and I misspelled principal, okay, as you can see. Misspelled principal. This is your starting amount. What are we investing? R is your rate. It's usually given as a percentage. Please make sure you change it to a decimal, 2 places to the left. N is the number of times a year it's compounded. So if it's compounded annually, that means once. Quarterly is 4. Okay, biannually is 2. Those daily 365. Okay, that will be your N. And then T is your time in years. How many years are we going with? Okay. So here's an example to where we're going to see the difference between annually, quarterly, and daily. Okay, which one you want your bank to do. So we're investing the same amount of money at an interest rate of 8%. So that means our R is 0.08 and our T is 10 years. Okay. So the difference here in these formulas is going to be your N. So in this case, N is 1 because it's annually. So N is here and here. Quarterly is 4 times a year. Okay, and then daily is 365. So you can see how those formulas change. Okay, and then you want to put them into your calculator, and you end up getting these 3 values. So ultimately, you would love it if it compounded daily. Okay, most banks do not do that. Most banks do quarterly. Okay, quarterly. So the middle one is the most common. Okay, but that's something to look at. You know, does it compound annually or quarterly? Now, if it's compounding continuously, so this is if it's doing 365 days a year, that means it has a special formula. Okay, so this is our continuous compounding interest. Okay, A equals P E to the RT. A is our total again, R is our rate, T is our time. Okay, so it has our natural exponential using it. Okay, so for this one, we want to know how long, so that means we want to solve for T. Will it take for $1,000 to triple? So that means we want our final amount to be $3,000, but our initial amount, our principal, is equal to $1,000. Okay, and it's invested at 0.05. So substitute in. We're going to solve for T. So that means I want to divide by 1,000. Take the natural log of both sides, because again, we're working with our e, and natural log of e is 1. Okay. We can bring down our powers and then divide by 0.055 on both sides. So again, it says round to the nearest year. So t is 19.97, but so it's approximately 20 years. Okay. So again, exponential growth and decay and looking at interest. There's some you can try here. If you have any questions, please reach out and I can help you with that. And again, we are coming down to the end, so please make sure that if you have questions, to please reach out. Have a great day.